Okay, as we look at A3, adding and subtracting rational expressions, remember a rational expression can be written as 1 over x minus 2, but now we're going to add it to something maybe like 2x over 3x minus 4. We're going to have to get common denominator here. So it's going to be a little bit tricky. We will be doing some multiplication in that, but it is going to be a little bit different than what we have been doing. So you're going to need to watch this and pay close attention. Now we'll start off with a nice easy one, add and subtract, but notice here, both of these have the same denominator, okay? X plus 4, x plus 4. So x plus 4 is what we're going to end up with. And basically all we have to do is add like things up top. So we have an x plus another x would give me 2x. Negative 3 and negative 2 would give me negative 5. So that one becomes very, very simple because we are just adding stuff like stuff at the top because we have the exact same denominator. So if that's the case, we also want to express where it is undefined, which we have been doing all along on these. So express where it's undefined. Of course, we're going to set that bottom or that denominator equal to 0. Subtract 4 from both sides. So x cannot be negative 4. So if we add them together, it's this. And we also want to clarify that x cannot become negative 4 because that's where we would be undefined. So that one's pretty nice and simple since we do have the same. Let's do another one like that. But this one's going to be minus. We're still going to express where it's undefined. And since it is a minus, we're still going to have x squared. Oops, there we go. Happens all the time. We're still going to have x squared plus 1 down here. Up here, we're going to have 3x minus 4, but it's minus, so I need to distribute that. So it's going to be minus 6x minus 1. Combining like things up here, we're going to get negative 3x minus 5 over x squared plus 1. So in this case, we still had the same denominator, but it is a subtraction. So we distribute that negative out over those, which change these signs here, okay, which change those signs, and then we combine like this. Now, is there anything x can't be? In this case, there isn't. X squared, no matter what, we're always going to get a positive number there. So there are no values of x that we cannot use. So it is not undefined anywhere. So there's no undefined numbers for this particular problem. See what you can do with this one? We really have the same denominator again. This becomes really quite simple. X squared minus 3 down here. And since it's a plus, we don't need to do much except combine like things. 9x plus 4. So there you have it. But we do want to take x squared minus 3 and set that equal to 0. Taking the 3 to the other side, we're going to have x squared equals 3. And now we're going to take the square root of both sides, so x equals plus or minus square root of 3, or in this case, x cannot equal those. So if we did put the square root of 3 in here, it would be the square root of 3 squared minus 3, and that would be 0. Even if it was negative, it would be negative times negative. It would still be a positive 3. 3 minus 3 is 0. So we cannot have the square root of 3 as one of our domain or input values. So there's the last of the easy ones where we have the same denominator. Let's go ahead and step it up a level with something. Whoop, we still have another one, the same denominator. Go ahead, let's see if we can do this one. Again, it is a subtraction. So think of expressing or distributing that negative. We're going to have 3x squared minus 5. Now that's got to be distributed. Negative 2x squared, positive 3x, and then positive 2. Still, all of that over our same denominator, since we have it, was very convenient. Combine like things that we might have here, okay? X squared, we have 3 positive and 2 negative, so it's going to give us 1 positive x squared. We have plus 3x, and then we have negative 5 and positive 2, which gives me negative 3, and that is going to be over 3x minus 1. Still want to figure out where it's undefined, so again, we're going to take this 3x minus 1, set it equal to 0, plus 1 on both sides. I'll come up here, we're going to have 3x equals 1, divide by 3, and x cannot be 1/3. So it's taking that denominator, set it equals 0, and solving for x is what would make our denominator go to 0. All righty, hopefully you're hanging in there. That's the easy one. Don't forget to always distribute if it's a subtraction. We've had the same denominator the whole time, so we want to take that up to the next level with a denominator that's not the same. And here we go. All right, we're going to take this guy right here, x minus 3. We're going to factor that trinomial. And I like to put them all in brackets here. We do have a plus sign between them. And this is going to factor to x plus 4 and x minus 1. And we still have 2x here. Put that in brackets. And we're going to have x plus 4 here. So we're going to add these two things together. And we need this common denominator. And what would that be in this case? It's going to be x plus 4 and x minus 1. Well, you'll see in this second equation over here, I happen to be missing part of that. So it's real simple. Whatever I'm missing, I'm going to need to multiply by that. Just like you were looking for a common denominator. So I'm going to multiply that, but I do have to do it on both top and bottom. All right, I'm not going to FOIL that out down there. I'm going to let that go as x plus 4, and you'll be able to leave it like that on any assessment, and x minus 1. Okay, we got a little work to do here. I'm going to take and distribute this, but I have this to come along also over here. Okay, so I'm going to have x minus 3 plus 2x times x would give me positive 2x squared, and 2x times negative 1 would give me negative 2x. Almost done. We're going to need to combine like things here. So let's do that next with what we have here and put it in standard form. 2x squared, right? We have a 1x minus 2x, that's going to be minus x, and then minus 3 all over x plus 4 and x minus 1. And then our last step, of course, is going to be to figure out where it's undefined. Hence, that's why I didn't FOIL this out to start with. So we're really, x cannot be what? Well, in this case right here, it can't be negative 4. And in this case right here, it can't be positive 1. So there you go. You have added those together. Remember, whatever we were missing in the denominator, we just multiply both top and bottom by that. And it's pretty straight up for you You're really gonna need to practice this a little bit. It'll take some time. Make sure you're diligent and try to do those problems today in class or tonight. Let's try one more. So as we look at this, we always want to start, if we need to, by factoring. Difference of perfect squares, x minus 2, x plus 2. I always like to put these things in brackets, okay, because it helps me think about, I do need to multiply, okay? So I look at this denominator, and what am I missing? I'm missing x minus 2 on this side. So that's all I need to really do is x minus 2, both top and bottom. Okay? So now I know that my bottom is x minus 2 and x plus 2. And now I'm going to distribute here. So I'm going to have x times x squared. I'm going to have negative 2 times x, which would be negative 2x. And then I'm going to have nothing else here, but this negative 8 needs to come along. And there you have it. So all that's left to do is figure out where we are undefined. We have added those together. Think about where we're undefined down here. X cannot be what? Well, it can't be positive or negative 2. So we got to get that same denominator. And whatever we're missing on either side, we are going to multiply it by that. This will be a little bit more of a step-up problem. Our last one I'm going to do for you. So let's take a look. We have 3x minus 2 over 2x plus 5. We're going to subtract 2 over 5x minus 2. Now what makes this one fun is that we are missing everything. I'm going to go ahead and put some brackets around these, remembering that is a minus. So over on this side, I'm going to need to multiply by 5x minus 2 because that's what I'm missing. And I'm going to both do top and bottom. On this side, on the other hand, I'm missing 2x plus 5. And I need to do both top and bottom. Okay, now we got to do some multiplying. So let's start here. We know what our top and bottom is going to be. I mean, we know what our bottom is going to be. 5x minus 2 and 2x plus 5, right? But we're going to have a lot of stuff up on top to go with. So we start right over here. 5x times 3x will give me 15x squared. 5x times negative 2 will give me negative 10x. Negative 2 times 3 would give me negative 6x. Negative 2 times negative 2 would give me positive 4. So that takes care of that side. Now remember, here we are subtracting. So I'm going to go ahead and just carry that as a negative 2. Negative 2 times 2x would give me minus 4x. Negative 2 times 5 would give me minus 10. So hopefully you're digesting that a little bit. We're real close on this one now. Okay, we just need to finish it off by combining like things. Here's my 15x squared. Here I have a minus 10, a minus 6, and a minus 4. Looks like that's going to be minus 20x, right? So those we've taken care of. We're going to have a 4 plus 4 minus 10 gives me minus 6. And again, that's just taking care of that business there. We still have 5x minus 2 down here. And we still have 2x plus 5 here. So we've effectively subtracted them. All we need left to do is figure out what x can't be. So let's set that first binomial equal to 0. I'm going to plus 2. and get 5x equals 2. Then divide by 5. And my first one, x cannot be, is 2/5. That's my first value, x cannot be. I'm going to take this second one over here, okay? And we're going to set him also equal to 0. Not changing color, trying to anyways. 2x plus 5 equals 0. Take that 5 by subtracting. It'd be -5. Then divide by 2. And now we're down to our last one. X cannot be -5/2. So it can't be these values. And we've added them together. Or in this case, subtracting, I'm sorry. Now this one was unique because really we were missing both things. Up to this point, we hadn't had that chance. So there was a little bit more work to do. Make sure you have, you're going to carry that negative when you multiply here since it's subtraction. So remember, whatever we're missing in the denominator, we need to multiply both top and bottom by that. Try to do these problems if you can. I will let you see the answers now so you can possibly check your values and see how you can do. And hopefully you can hang on with these and do pretty well. All righty. Thanks a lot. Have a good day.